Hello and welcome to part 4 of our fireworks project. In this part we're going to go over everything we need to do to get our scene fully render ready. Now since the last part I have actually tweaked some of the timing and I've sort of spaced out the display a little bit more so that they've got a bit more breathing room between the fireworks, and I've also extended that timeline. But I've also added an extra couple of fireworks to really sell that crescendo. So if I jump into the hierarchy of fireworks here, you can see I've added a couple more willows. And if I hit Shift F6, I've actually already rendered this as a hardware preview just so we can see how that looks in real time. So we've got our initial peonies coming up there, then our bombettes and their secondary fizzle, and then this is where the big crescendo happens, and just having those extra two really sells that big finish. Okay. And we also have this null here called trees, and of course if I jump to the layer browser and I unhide it from the viewport here, you can see that it's simply, and I expand that out actually, you can see it's polygon object trees that I've actually pre-placed based on some sort of testing, and I just want them in there for sort of foreground, catching the camera in the foreground. Really they're just going to be silhouettes. So the first thing we're going to need to do to make those somewhat relevant is to actually work out a camera move. And I've got the idea of having it kind of swinging around the display. So what I'm going to do is I'll temporarily hide those trees again. And let's add a camera system. Because we want this to look a little handheld and a sort of fairly realistic camera motion, I'm going to utilize the motion camera from Cinema 4D. And you can find that if you hold down on the camera icon up here, and you can see we've got this motion camera. When I add that to the scene, let's jump back to frame 0, zoom in. You can see here we have this little camera operator stick figure. It's sort of to represent the height off the ground essentially, and that's all controlled in the motion camera tag. And if you look here, this is actually just a normal Cinema 4D camera, and it has this motion camera tag, and it gives you all these extra sort of options for inertial motion and things like that. But we're going to keep it nice and simple. We're going to work with sort of the basic elements of it. But first things first, let's look through that camera. So there's a few ways you can do that. You could just double click the camera icon there, or you could even just click that use camera icon. And then because this is our users render view viewport, it's viewing it through there. Now let's view all the viewports at the same time. It's probably the best way to review things at this point. And if we zoom out of our top view here, I'm actually going to take this path spline and I'm going to move it back along the Z axis, and you know, kind of towards the bounds there of this particular floor. We're going to be replacing this floor, but let's take the target now and let's move that up a little bit. And I can already tell this is definitely going to need a wider camera lens, just as you would in real life. To capture a fireworks display, you're going to need a wide lens. And you can find all that stuff in the tag. So jump to the motion camera tag, grab focus, and then I'm going to go for a pretty standard wide lens, which is a 24mm. And that will allow us to frame up as much of our fireworks as possible. I'm okay with a little bit going off frame, but you know, we want to definitely capture as much of it as possible. So let's scrub along. Where the main bit is our crescendo here, and you can see that's definitely wide enough to capture those. So excellent. And we could even bring the whole camera rig back by grabbing this path spline here, and let's just move that back a little bit further, looking at the viewport. Somewhere like that. And then we could just scrub around a bit, just check that that's all good. Yeah, definitely wide enough. Okay, so now let's actually animate our target. Let's come back here to frame 0 and let's set a start point. I just want it to be above the platform, and then if I activate the auto keyframing, and it's going to remain sort of viewing this area of the display for about 3 or 4 seconds. Well, let's have a look. Sort of pretty much to this point where the first peony has kind of rocketed off. Let's add a keyframe there as well, or we could just nudge the target because we want it to be quite natural. It doesn't matter too much if exactly the same positions are between these keyframes. So let me just nudge this one a touch. And that adds an automatic keyframe. And then if we just scrub along, it's about here where the peonies have kind of started exploding. And like I said, I'm quite happy for some of them to detonate off frame and have their brakes off frame. So let's come back. We'll confirm all this timing with a hardware preview, of course. And then we want it to sort of stay at this same kind of level, waiting for the bombettes. And they've just started, so we can probably nudge back a few more frames. And this is where it's going to start. Well, let's add another keyframe here. Just move it slightly. And then let's move on a few frames. See where the bombettes explode around about here. About 250-ish. And we lift that up. And of course we can move left and right as well if we want to center them and that kind of stuff. So let's just bring it to the right a bit more there, just so it's not all staying centered. Just as a camera wouldn't follow it completely straight like that. Then let's just move on to the next event. Well, obviously the bombettes have a secondary explosion, so perhaps we want to follow that up a little bit further as well. Just catch that nicely in the air. And sort of in preparation for these other ones as well. There we go, another keyframe there. And we could even bring it back down again a little bit. So maybe we come back towards the center, jump ahead a bit, and then it kind of follows them back down in prep for that final crescendo. So, you know, the operator's following the sparks down. And then we've got our big crescendo here. And we're going to follow those fireworks up. So we want to start here around about the first sort of explosions. And then we'll just lift up the target so that we've got enough headroom basically to capture the whole detonation. There we go. Okay, so now we've got that blocked in and I'm pretty happy with that. We can take a look at the actual path of the camera. And we have this, the path spline is what's dictating that. But I also want to be able to see our trees. I'm just going to turn off auto keyframe. It's always good to turn that off after you're done with the animation. Go to my layers, turn on the trees. And then we want to actually animate our camera along the spline. So currently there's no animation keyframes. If we go to our motion camera tag, go to the attributes manager. And if we look at our animation here, you can see that we have this camera position A, and that means essentially along spline A, which is the one we've assigned, I can move it along that spline using this parameter. And all I'm going to do is very simple. It's just add a keyframe here. So just hit the keyframe here, scrub to the end, and then make that 100%. And I'm also going to make those linear because essentially I want the animation to start as if it's been cut into the camera person's movement. So I'm just going to Control A or Command A on a Mac on the power slider here, whilst you're hovering over the power slider there. And I'm going to change those to linear interpolation keyframes. And that's going to be moving immediately. There we go. A little hard to see because it's a very small motion. And we can fix that by setting up our points to be a nice swooping arc under these trees here. So first of all, let's have a look at the spline itself. And you can see here, now it's a little hard to see under these trees in the top view here. So what we could do is we could make the display here only display boxes in this view. So if I go to display and I'm going to set it to box. Now the slight problem there is that it changes the spline to a box display mode as well, but we can fix that if we just right click and then we can just add a display tag. And then we can just use the standard garage shading. So there we go. That's a bit of a clearer view in the top view, but it still lets us see everything in the other views. So what I wanted to do is I actually wanted to reduce the number of points here because this is a little bit too many points. I just want it to be a very simple 3-point curve. So I'm just going to delete a few of the points until we've got 3 left. And then I'm just going to position give it a start, a middle, and an end. And then we'll scrub the timeline to see how that positioning is. So at the very beginning, oops, there we go. Want to be under the trees, quite far back. But I don't want to be so far back that we can't see the action. So I'm going to push it forward a touch. There we go, maybe somewhere like that. And then let's go to our middle here. And this spline, when you add it via the motion camera tag, it's actually interpolated as a cubic spline. And you can give it some more sort of interpolation, but this is such a shallow curve here, it shouldn't be too much of a problem. So we swing round, and you can see that really adds to the parallax, having these trees in the foreground like this. So I just want to position this middle one, and let's move that. Oh, we're intersecting with the tree there, so we want to avoid that, of course. It's not far off, actually. Probably a middle point, somewhere like so. And then, yeah, look at that. That's just catching the top, but not obscuring our fireworks. That's the intention here, is not to obscure the nice, especially the bombettes. They look cool, so don't want to miss them. And then we scrub towards the end. We have this kind of larger one just coming into frame at the end. And then the very last keyframe is right underneath. That's probably a little too close underneath there, so maybe just push it forward a bit. Actually, well, since the fireworks have finished at this point, having these foreground trees swoop in here is nice as well. So we'll stick with that one. As ever, you tweak away and make it suit your simulation. But there we go. That's our camera ready to go, and we'll test that with a hardware render in a minute. But the last thing I want to add is I want to add a breakup to the horizon. So we're going to add a bit of a terrain in, but a very simple terrain. So first off, I'm just going to grab this plane down here. So let's go to object mode or model mode in the browser. And then if I look here, we've got our floor plane. Now this is the collision floor plane we have related to the structure here. So what I might do is I'm going to duplicate that one and then I'm going to get rid of that tag, and then I'm going to hide the original collider. There we go. So this is going to be our visible plane with sort of undulating terrain just to break things up. But obviously we need to make it much bigger than it is right now. So let's scale that up. Way up, like as long as it's sort of big in the horizon here. So let's do something like that. And then we need way more subdivisions. At the moment, we're viewing this view in box mode, remember? So let's change that back to wireframe. And you can see the divisions of this floor plane are at the default 20 by 20. Let's increase it. It doesn't have to be crazy dense here, unless you're doing some extreme detail, but that's more of a sculpting thing. This is just to break up the horizon, remember? And I'm going to use the Sculpt Tools for this. So I'm going to use a sculpt brush, and we need to be in a polygon mode. So we need to make our floor plane editable. And you can either hit C, or there's a button up here which is make editable. So I could just hit that and it turns it to polygons, and that'll enable those brushes for us. You can break away this menu here and make it a little bit easier, so you can use these different brushes. The one we're going to be using is pull, sort of the default brush here. And we want to maintain our camera view. We want to make sure that we're looking at our shot camera through one of the views. And then in this one, to make it nice and easy, I'm going to make this a perspective view. So I just go to cameras here, change it to perspective. And then if I change the display to like, say, quick shading, then we can zoom out. That just makes it a little bit easier for us to work on this scene. So if I zoom right out, remember we're working on the horizon. So what you want to start doing is just start brushing and seeing what it does in your main view, like so. And you see it brings up the horizon there, and as we move around, you'll get some parallaxing. To encourage the parallaxing, you'll want different levels and different positions of these mounds, so, or the changes in height in the terrain. So if we bring one here, like so, maybe soften that. If you hold shift, you can soften everything and brush. There we go, that's looking cool. Maybe bring that around a bit further. Like so, and then, I mean, by the time we're here, we're actually looking up, so it doesn't really matter too much about the dressing. I might put one larger, if I hit Control, Shift, and then middle mouse drag, you can actually scale the brush up. I'm just going to bring this back area up here until we can see it in the main view. There we go. Just so we've got a bit of depth to this as well. There we go. Now, as we're moving around, obviously, like I just said, we look up. So there's a point where it doesn't actually matter, so we're not seeing any more detail than that. So the terrain, just to break things up, is absolutely fine. But if I hit, well, if I actually, let's scrub back to 0 here, you can see we have safe frames, and the safe frames are essentially our 16:9 render ratio adapting to the viewport. So the viewport isn't quite 16:9, so it adds these safe frames, but they're very, very faint. And especially when we add a dark sky to this. So if I added a viewport sky, so just add a sky like so, and we can just make it dark. If we turn on the use color and make it dark, and then in this viewport, we're currently viewing it in layer mode. So we just go to options, layer color, like so. And that's a bit more representative of what we're going to see. I think it's going to be a bit more blue than that. So let's just, this is just for the viewport, remember? Just tint it a bit blue. Something like that. So it's going to be a night sky. There we go. But the issue is, and I've closed the brush, you can see how faint that line is, or maybe you can't see. And if you hit Shift V whilst you're on that viewport, and you go to the display tab, the view tab, and you increase the tinted border opacity to 100, you'll see it much clearer. And sometimes if you're on a black background, you cannot see that at all. You can just adjust the color. And the gamma shifts a bit crazy on this, so you can go really subtle on the colors and you'll see it jumps to a color like so. There we go. So those are our save frames, and having it as a color kind of makes it very obvious where anything is in frame and where anything isn't. It's just a little tip there. And now we can also get this ready for the hardware render, and just to check all the timings and everything and see how things are feeling. I'm going to add this dark material to the ground as well, this grey material. It's just a viewport material for now, like so. And then we can add some filters to our viewport. So anything we see in this particular viewport, which is our use as render view viewport, will be sent to the hardware render. So we will see all of the splines, we will see all of the motion camera setup and things like that. That's actually the very intention of a hardware render, but we don't want all the clutter. We just want to see the particles. We just want to see, you know, nice clean camera move and check it for timing. So I'm going to hit Shift V, and we get the filters down here for this perspective viewport. You can also access them from this menu, but you'll just have to keep going back into it once you uncheck one of them. So this is a bit more of a user-friendly one if you're doing multiples at one time. So I want to turn off a few things here. I'm going to turn off my grid, horizon, and my world axis. So you can see that's cleaned that up there. I also want to change I don't want to see any nulls. I don't want to see any splines, and you see immediately they go away. I don't want to see any cameras, but I'm also going to say I'm going to hide the motion camera setup as well. So if I hold Shift and Alt or Shift and Option on Mac, and I just hide that motion camera setup from the view anyway, that's not a problem. If I hit F1, we'll jump to the main view. And I think that's pretty good. Now there is an option here called Particles. Let me just find it. Particle, there we go. And it's actually not X-Particles. It is more for things like the display of the sort of the modifiers here. So you can sort of check that on and off if you want to clean those up as well, but you'll still see the particles. If we just scrub, you can see we get this nice clean viewport from start to finish. Got our tree nicely in the way there. And I'm noticing the camera is wobbling a little bit too much. And from experience, I know that that's going to be quite fidgety. So what we'll do is I'm going to preemptively reduce that down. And all we need to do is jump into the motion camera tag, jump to the motion tab. And by default, these are set quite high. So they're currently at 100% each. Now, if I jump to a Steadicam preset, that's kind of adds 50% onto the head rotation, and then these are still at 100%. I like to kind of reduce these down, probably down to about a third. And I've got some sort of settings that I like to have. And those should be much steadier. So what I'm going to do is I'm going to render this out to the hardware preview. So let's just double check our range. So we're rendering 1280 by 720, which is 16 by 9. That's good. And then we're rendering all frames 0 to 560. And then it's enhanced OpenGL. I'm not saving in this case, so it's going to warn me when I hit render to picture viewer here. And I just agree that I don't mind that it's not saving. And then we let that render to the picture viewer. And this will render pretty fast. It'll render as fast as it can display in your viewport, essentially. I mean, it depends on the resolution and super sampling, but it's very quick to create your previews. So here we go. We're getting a nice idea of the foreground, and we're going to throw these out in depth of field. And then we've got our fireworks display, of course, which I'm pretty happy with the timing on already. So really, this is just about reviewing the move as a whole, the display as a whole. And we can watch this whilst this is still rendering, so I can hit play. You might get a slightly hitching playback. You want this 30, this FPS down here to be the same as your playback. And when it goes red, it means that it's a little bit under that. So here we go. Nice bombettes. And we're going to have an HDRI in the sky when we render this as well. So it should look pretty cool. And there we go. We've got our nice willows overhead. And you can really see the parallax is helping. The motion in the camera is really sort of selling the 3D and position of all the, especially here, look, you can see the willows as they hang in the air a little bit longer. You can really see that rotation on the camera. And of course the foreground tree, which is essentially a wipe to get us off onto the next thing. So let's play that all the way through, unbroken. It's looking cool. Nice clear sky to see the particles. And I'm happy with that. Great. All right, so now that we have our scene ready to go, we can jump into Cycles 4D. And we're going to need a couple of things from there. So if we jump up to the top menu here, Cycles 4D, and we're going to need mainly the real-time preview. This is essential. Now this is like you can imagine this as a viewport, except it renders in real time and we get beautiful kind of light calculations and path tracing. And we also want, now this is fairly optional, this is the node editor. And what it does is if you click on a Cycles 4D material, it will show you the node graph for that material. And I tend to like to have that up all the time. When I say optional, it's not optional in terms of if you want to interact with the materials. It's optional because you can just double click the material and bring it up as a floating window at any time. Now I like to have both of these docked, and I actually have saved that into a layout. So jump into the layout, and I recommend you save one of these if you're using it a lot. And then we could just start the real-time preview, and it'll load stuff into the scene. But we won't see anything yet because we have no light in our scene. Now, Cycles 4D, if you see, we have the sky for the viewport here. That's only for the viewport, and I'm going to hide that now. And I'm going to add a Cycles environment, so Psi environment, and then that'll add to the scene. And by default, that actually adds a background material, and this background material has an HDRI link to it if you've set an HDRI location in your preferences. So if I actually jump to the Psi environment object, you can actually hit this button here, open HDRI. I've only got one loaded in for this particular training just so I could get to it nice and quickly. But you can see I've got a couple of options. I've got the 8K version and the 16K. I'll go for the 8K in this case. And that gets then sent to the RTP and we can see it in there. Now I don't want to see the light in the background here, and I kind of want to get a different view of this. So what I'm going to do is I'm actually going to rotate the environment object itself. Now you can do this interactively in the viewport, or you could just use the, I like to just grab the heading value here and just rotate it around. And you can see here, I've got a few sort of interesting parts of the background here. I might sort of swing it round, and remember we're gonna swing round as well. So this is kind of the key moment where we're seeing the horizon here. Maybe just nudge it around. I quite like these pylons in the background there. And it's currently too bright. Really, we're having the fireworks. We want them to really stand out against that background. And we can do that by reducing the brightness of our HDR. And if we jump to our Psi environment object, HDR, and then we can use this brightness slider, nice and simple. Now if I go to 10%, even half that actually, so 5%, you can see it's still giving us a very subtle silhouette, but it's going to be a nice dark background to contrast our bright fireworks. And that's what we'll do next. We'll add some materials for the fireworks. And obviously fireworks are going to be emitting light as they burn their materials, so the different chemicals give them different colors. And we'll just start really basic. We're going to just use an emissive material. Now there are some nice presets that Cycles 4D has for X-Particles, and we will come to those in a minute. But I'm just going to start very simple in the surface submenu here, and I'm going to add an emission shader. So this is an emission Cycles material, and this particular thing here is an emission shader node. So when they're blue, they're shaders, and it's connected up to the output. Now if I just drag this simply onto our entire fireworks hierarchy, so everything underneath it will get this material, Cycles 4D detects that there are emitters in the scene and actually renders the particles for us with that material attached. Now I'm going to jump into a slightly different camera here. Let's jump into our viewport camera, and let's take a closer look at the scroll particles here. So if we zoom in, we can see that they are rendering as little spheres. And that's the default Cycles 4D sort of render shape. And we also have control over this after we've cached, after we've simulated. We don't have to recache or anything. So if I directly attach this material to this, it'll do the same. However, we can add a tag. And this tag is called the Psi Instance Tag. So right click, Cycles Tags, Psi Instance Tag. And what this does is you won't see any difference because it's at default. It's exactly the same as just having the material on there. What this gives us is it gives us control over the sphere segments. So if I drop it to 3, we'll see almost sort of triangles or pyramids. And if I increase it one step at a time, you'll see it gets more subdivided. Now, because we're dealing with such small particles from a distance, we can actually get away with quite a low value here. So perhaps we go for an 8. And then even just from this distance, they will look nice and spherical. We also have control over the size and radius of them. So if I drop the size multiplier right down, you can see we get much, much finer particles. And we will be doing this, we will be tweaking and tuning these to this kind of value. We also have control over the size variation. Now, because we've cached the size variation into this emitter, we don't really need to do that, but we can still use that slider and it'll multiply that stuff. And you can see, because I've gone beyond the 100% value, obviously, we get some very large particles. Okay, so that's the Cycles instance tag, and that's great for creating variation after the fact. You can also drop a custom shape into the objects here. So if I actually drop let's drop a cube in, make it small, and then I'm going to drag it into here, and then I zoom in. Now you'll see it's gone dark because the material is assigned to the emitter and not the instanced object. So I'll just drop that onto there, and you'll see, there we go. So if you need a custom shape, you can do that via that. But we're fine with the small point sizes, like so. And now we can deal with the color. And there's many different ways that we can color our particles. And one is, of course, to just directly change this shader's color. So on the emission shader here, the emission shader node, I'm going to give it a color. Now I'm going to give it a really oversaturated color just to demonstrate something. So let's go for a very vivid green. Now you'll see that the green is nice and accurately represented in our real-time preview. But what if I want to make this get really hot? And hot things in a camera would expose to white eventually if they, are several wavelengths of light being emitted from them. So if you imagine that this is getting hotter, so we're going to give it more energy and higher brightness value, higher strength, you'll see that it remains that same color. And the reason is that we're at this full saturation point. So it's as if the color is only one wavelength on the spectrum, and it's not including any of the other ones. And in reality, that's just not what happens. It's very rare to have an object give off or reflect a single wavelength of light. It's usually a cluster around a specific wavelength. And you can kind of simulate that. So if we look at our RGB slider here, in fact, if I just drag across and hold Shift and show both my HSV and RGB, you can see that we've mostly got a green value here. But if I drop down the saturation, the other values come up and it actually becomes a bit of a softer, less saturated color. And you'll see in the real-time preview that we're now getting this really nice looking hot value, but the core emission is still green. So we're getting cast light that is green onto that surface. So obviously this is a bit of an extreme color for our fire color here, our fire particles, I should say. So I'm going to make them a warmer color, and I could even jump into the Kelvin slider to get a kind of a natural warm color like that. And there we go, we get a nice warm color, and I could even desaturate that further until it gets that hot white and looks pretty cool. And of course, if I zoom out a touch and I scale our particles down, it's going to change the look again because we've got so many particles adding to each pixel at this distance. We're getting quite a hot look. But if I scale it right down, so we go to 30%, you'll see it looks a lot more natural and it's not getting quite as hot. But if we did want it to stay hot, we could pump the brightness again. And there we go, back to that kind of white value. But I preferred that value at 5, and we'll set the scale up a bit to 50. Okay, so that's one way to set the color, just directly setting it in the node here. And I can change it to an artificial color there, like a green. I mean, it's not artificial, it's a color that's not even close to the particle color. But what if we wanted to pull this particle color in and have it render in cycles here? Well, we can stick in the same node graph, and we can go to Input, and we can find this thing called Particle Info. You can also filter it using the search here, so I can start typing particle and it'll filter down. Drag that into our node graph, and then we're presented with this node full of interesting looking attribute outputs. And so this is all the data you can pull in from a particle info node. So I want to have a look at the color, so I could just solo that particular channel, and you'll see it is now pulling in the color from the particles. So if I zoom right in here, you can see this one here, these darker reds here as they're smaller, and what I set them to before we cached them. If I zoom out and I apply our material to these other emitters as well, so if I just drag that onto the top of the hierarchy again and have that load in, you'll see that those are now green. They're the green color that we had them when we cached them, and so on. So if I went to a bit earlier with the peonies, they had a pink color like so. And you can see they're that vivid, oversaturated color. Now, if I pipe that into our emission, and it's obviously being pushed beyond its value, you'll get that kind of whiting out again. And we can, of course, we can also treat this just as any other color input. We can adjust it using the color sort of correction facilities here. So we've got one node called HSV. And if I just drag that in between and connect it up like so, we'll now have the ability to adjust the hue. So I can just shift the hue around. And you can see that's changing. Now let's put the brightness down so we can see that color nice and clearly. So you can see I can tweak the color after I've cached and simulated. And it's doing it to all of the colors because I've got them all connected up on the hierarchy. So I'm happy not to have that. So I'm going to shake that one out and delete that. And that's obviously a nice way to be able to cache the color into the particles and then have cycles just read those in. So let me just pump the brightness back up a bit. But what if I want to control the color of the particles based on another input. So here we've got all these other ones. We've got age, velocity, radius, that kind of thing. And radius is one that I'm interested in. So all the tail particles and all the finer sparks like this, I want them to be colored based on their radius. So what I'm going to do is I'm going to solo the radius, and we'll take a look at what we see. And you can see there's very subtle gray values. Even though we've got our emission strength all the way up at 5, we're only just seeing the particles. And there is some variation, but it's not very clear. So what we're going to need to do is we're going to need to tell Cycles what the radius of our particles is and that range, and remap that to something more usable. And what I'm going to use is I'm actually going to use a group that I created in a bonus video of this series. And you're welcome to go and watch that. It's called range mapping. And we go through the process of why to create something like this and how to create it and all the math nodes. If I just jump into it quickly, you can see it's made up of these 6 math nodes, and we kind of convert an equation for range mapping into a usable node. But you don't need to worry about that. If you just want to install the rangemapping.cyg to Cycles, you'll be able to access it here. So what I'm going to do, and it'll all become clear what this does in a second, I'm just going to connect these up to our emission, and I'm actually going to make our emission 1 in strength again, just so that we get an accurate representation. And I'm going to unsolo the radius data parameter there. And I'm also going to add a color ramp. So here's our color ramp. And we're going to use a bit more of a diagnostic color, or diagnostic gradient. So I'm going to load preset here. And there's a bunch of sort of colorful ones I have saved and stored in here, but the one I'm interested in is default one called Heat 2. And if I click on that, what this will allow is for me to tell when our ranges are fitting within the right sort of zone. So currently our radius is way too small, and therefore we're only seeing them down here on the blue. And we can think of our input on this range mapping group as 0 size in radius. So the input is a radius value. So the minimum possible radius is 0, and the maximum possible radius is 1 meter. Now we know that our particles are much smaller than that, and if I click on our XP emitter, and we see here the radius value is 2 with a variation of 1, so therefore the smallest emitted values are 1 and the maximum is 3, but we also scale our particles down to 0. So really our range is from 0 to 3 units, 3 centimeters. And because this is in meters, I'm going to change this into meters. So you could do 3, and then you could just do divided by 100, and that would give you your radius value. And immediately we can see that our particles are now respecting that range and in Cycles, and we can see we're actually getting the red value. So the largest particles are showing as red, and the smallest ones, even though they're obviously going to vanish from our scene, are blue. Now, just to show the proof of concept is working here, if I change the output, so if I change the output to 2, you'll see that a lot of our particles become red. And that's because I've told the output of this to be 0 to 2. So it's double the length of this. If you think about the position of the nodes on this gradient here, so you can see the position is 0, and the position is 100 of the last one, that the 2 is essentially 200%. It's beyond the range of the ramp, the color ramp here. So we need to leave that at 1 maximum to get the full range. And if I did it at 0.5, that's essentially only going to sample half of this color ramp here. So you can see our range is only that half of the color ramp. And it goes likewise for the minimums as well. So if I put the minimum to 0.5, it's going to start here, and then the maximum is going to be here. So that's 0.5 on the output minimum. Okay, but that's a great way to color your particles based on data that's come in. So you can use this for all sorts of other data inputs as well. You could use it for random. So random's really interesting. If I just connect random up to our diagnostic gradient, you'll see that we get the full spectrum of colors. And what random is doing, if I solo it for a second, It's essentially just assigning a random value from 0 to 1 to all the particles. So every particle has a value between 0 to 1, and it's randomly assigned. And then because it's 0 to 1, we can ramp that value. And then if, say, a particle is 0.5 of a random value, it's going to be green. And if it's 0, it's going to be the blue. And then 1 is going to be red, and so on. So this is really, once you understand this, that you're just ramping and range mapping data, you can really take control of your particle colors. So now that we've got control based on the radius of our particles, and we don't have to recache to get that data, I'm actually going to use a really cool node called black body. Now, if I clear the filter there for the nodes list, and you can see here, we've got this subcategory called converter. If I open that up, it's the top one. It's called black body. We're going to drag that into the graph. Now, if I solo that out as well, we'll be able to preview it and see what's going on. And because it's a converter node, what's it converting? Well, it's converting temperature in Kelvin to a color. And this particular spectrum is a result of heating up a black body object. And the more you heat it up, it goes through sort of a spectrum of radiation, and it changes color and brightness. So if you look here, if I go through, this is at 1400 Kelvin, 2200 Kelvin, and you'll start to see we end up getting to the sort of white hot level. And eventually, like all the way up at 12,000, you get this blue color. So we're really going to be dealing with the colors down at this end of the spectrum. And we're going to use the range mapper to remap our radius values to simulate that temperature change. So I'm going to connect up the mapped value from our range mapping group. I might as well connect up our emission BSDF or emission shader as well. And you can see here we've got this, the range mapping group is set to the correct radii range, but not the correct input and output range. So I'm just going to change that to, say, let's go for 4,000. And you can see now we're going from 0 to 4,000. So we're clipping a little bit between 0 and 800. So 800 is the minimum. And then you get that nice natural looking color. And of course we can over egg the temperature here. We can pump the brightness values, that kind of thing. And what we will do actually is we will drive this strength with another range mapping group. So I can get rid of our diagnostic ramp for now. And I'm going to duplicate our range mapping group, and you can just hold Control when you drag that, and you connect that up like so, and then that can go into the strength value. Now this is going to be extreme values for the strength slider because they're still that 800 and 4,000. Really, we want that to be between something much more realistic. So maybe somewhere like that. Let's zoom out a bit and see what that looks like. Or even just go into the motion camera up here. And we can see there is our very hot looking fireworks. Now I'm just going to change the ranges to something I prefer. 1500 will just bring up, there'll be sort of less of the really extreme reds. And then I'm actually going to scale the particles down. So I'm going to go for, let's go much lower. And there we go. We're getting a much more detailed representations of our fireworks scroll, but it's in that natural tone, that natural sort of warm glow. Okay, so let's actually utilize, I'm going to use this material because this is now a versatile material that will just simply look at the particle radius and translate it to a black body color and then also a black body sort of emission. And I'm quite happy to let that be used for all the tail particles and these particles here at the beginning as well. So let's have a look at those. They've got the same material assigned, and let's jump into the default camera. Now, it looks like we've got the radii all the same on those. That's no problem. We can recache this. So if you look at the particles here, they're all this one color. And that immediately tells me that the cached particles don't have any variation in the radius. That's no problem. This happens in production all the time. You just need to adjust those settings and then we can recache. So let's go find those emitters, and we can do that using the search function. And I can already tell that it's the tail emitters. So I'm going to hit tail. And here we go. If I click on a few of these, we'll see, yeah, there we go. So the radius is all 3 with no variation. Some of them are 2, but we're going to set them all to 2 and 1 in the variation. So if I just select them all now, set the variation to 1 and the radius to 2. And then we can check the other ones as well. So I can see here as well, this looks like the fountain emitters are all the same radius as well. So we'll correct that at the same time before we cache. Like I said, if any of them don't have the radius corrected, we can always go back in and fix that. So because this is a pretty fast one to cache as well, it's not too much of a problem. But you could always create a single XP cache object and just isolate that to add a new cache for those particular particles. In our case, we can just do this all in one go. So we know these ones are correct because we've been working on these. These have that variation. And now once we recache, all the other ones will have that as well. So if I just look into the hierarchies here, let's just double check. So we've got our tail, just a spot check to check a couple of these. That's good. And the bombettes have their variation as well. Yes, excellent. Okay, so now I'm just going to recache that. Hit build cache. It's going to ask you if you want to create a new cache or overwrite. Now, we could create a new cache right now. That might be the safer option. So let's do that. Let's create a new cache and let that run. Now, from now on, once that's cached, it will use that new cache for all the data. Okay, I'm going to let that run. And then when we come back, we'll assess it. And then we'll be able to assign the rest of our materials. Okay, so that cached out nice and quick, only 3 minutes. And if I zoom into this set of particles over here, we can see there is some variation in the radius. Now, if I zoom a bit further out, that can be a little harder to see because they're all fairly similar colors. But what I can do is I can actually use our range mapping and a diagnostic gradient again, just to get a good visual feedback that we are feeding radius values into here. So if I duplicate this range map and I set it from the input and output to be a maximum of 0 to 1, and then we add a ramp, color ramp. Let's connect those two up and then connect the input to radius just like these other ones. And then if I solo out this color ramp, make it that nice heat to ramp, we'll get the colors there. And that's just a nice visual confirmation that we are getting variation in the radius. Okay, so now I want to tweak the actual render radius. So the radius that eventually ends up being passed to cycles, just like we did with the fireworks here. And I'm going to do it fairly custom for each of these. Let's start with the fountain. So let's open up the fountain. And in fact, let's just filter for emitters. XP emitter. And I'm just going to duplicate that Psi Instance Tag onto that particular one there. And that's the fountains. And I'm going to set that to a bit larger. So 25. And then I'm going to unsolo this ramp, this diagnostic ramp. And it'll go back to utilizing the black body setup. So I'm actually going to name this material now. I'm just going to call this Psi or particle black body. There we go. Just so we know which one that is. And you can see we're getting that nice variation in there. Now for the tails, I think having them quite large at the beginning, especially for the larger fireworks, if I jump into the camera, into the motion camera, having them quite large is actually quite nice. And they'll glow out really nicely. Now for the actual stars, we're going to create a custom material for each of these, but I just want to double check the tails on all of these. That's nice. So the bombettes are going to have their secondary explosions. Just scrubbing through to see that. There we go, that's looking nice. If I just scrub back a bit, there we go. You can see those colors coming through nicely. I think I'll leave those quite large, leave those at default. And then these are the really big explosions at the end here. Let's see what they look like when they explode. Very nice, but definitely too large. So I'm going to reduce the size of those. And those are the stars tails of the willows. So I can just filter by that. So I could just say, copy and paste that. And we can see that's those. And we can now right click those. And we can go cycles instance. And then I'm going to reduce that sphere segments down. Not entirely necessary, but just for there, I will. And I'm just going to drop them down to 30%. And there we go. And you can see immediately the color actually comes back into those particles. And you get that nice heat, but without blowing out to white completely. Okay, so let's just scrub back. I'm going to reduce the tail particle sizes here as well. So what I'll do is it's going to be the shell tail. So that's these ones here. And I'm going to make those a little smaller as well. Add another cycles instance tag. And then I'm just going to drop those by half. There we go. And can you see how the color comes back? As you drop down the sort of brightness there, the size of them, it kind of balances out nicely. Okay, and then we can just do a double check of the actual sort of warm black body particles, we can call them. Yep, looking good there too. Looking very good. And let's actually check with the fountain at the beginning as well. Just make sure we're getting some of that color. Excellent. And we'll add motion blur on the final stuff as well, so it's going to look really nice. There. Okay, so the last things we're going to do now is we're going to add custom coloring to the shells and the stars themselves. So, for instance, here, we've overridden this peony material, and you'll see when it loads up is that it's all that white material, and it's all extremely bright because it's well over radius. So we're going to first identify which emitters those are. So it's the Peony Emitters. So if I just filter for XP emitters, and it is the stars. So it's these three here that we're going to want to play around with here. So what I could do is I could just say stars, and then we get those all in nice order like so. And let's create a custom material for each of those. So let's just start with one, and we'll call this, let's call this one Psi Peony. And I'm going to start with a pink color, or maybe sort of a fuchsia color. So just again, as we had it at the very beginning, this is the nice and simple way to color things. So let's add that there, and that is this one over here. So you just saw it slightly dim, but let's change this color. Let's choose quite a vivid pink color. Give it a decent amount of saturation, but not overly. And we can see it in the render there. And let's really pump the brightness. So I'm going to go right up to the maximum of 30. And there we go. We get that nice hot color there. So I'm going to duplicate that one. And I'm going to call this one Peony Blue. And then I might as well duplicate the other one and call this one Peony Green. So let's set the blue one up. Add it to the middle one there, and then add that one to the green one there. So this one's blue, so we want it to be a nice gentle blue. Maybe a little bit more saturated. It doesn't, if you keep it within the same ranges as the other and just change the hue, that'll give you the nice sort of tonal similarity. And let's just scrub, make sure we can see that one in the view, in the render. There we go, get that nice blue. And then the last one's going to be green, so of course we'll just adjust this hue slider. And there we go. Get that nice green now. So that's a way of just overriding and just directly changing the colors. And you see they're not all exactly the same color. In terms of when they're larger, they're a bit brighter, and when they get smaller, they get a bit darker. So just naturally from the way they add to the pixel value. So there we go. And now we can move on to the coloring for our Bombette stars. So that's these ones down here. Now, if I just added, I could just add that green material on here like so. I could just stick with that. But I think these ones would look much nicer with a bit of a different way to color them. So I'm going to give them a few colors. And we're going to do that using random. So let's move that over to here. And let's duplicate one of these materials. We can just duplicate this one. And we're going to call this one Psi Bombette. I add the CY at the beginning because I like to be able to identify the cycles materials quickly. And let's just add those on like so. And now we can just make sure that that's the correct material. We could just change this color just to test it out. There we go. That's updating nicely. Okay, so I'm actually going to use particles, and I'm going to use the random that we had a little look at earlier. So I'm going to get the particle info node. So if I type info, you see that we get this particle info node. And of course, before we were grabbing the radii and the color, this time I'm just going to utilize the random. So I'm just going to pump the random into the emission there. And then I'm going to use a ramp, color ramp, like so. And what I'm going to do is I'm going to have the random drive a set of specific colors. Now currently it's blending between these values, but I'll show you what I mean. I'm going to open up the color ramp here. I'm going to select the first knot. Then I'm going to go to the color wheel. This is just a quick way of creating a palette. Let's, first of all, let's give it some saturation and value. Somewhere like that's good. And then let's add a few more knots to the color palette. And then somewhere like that's good. Doesn't have to be too saturated. And then I just drag that onto the color ramp up here. And we have these set colors. Now, what it's doing now is it's just blending between those nice and softly. What I want it to do is step between them. And therefore, what that means is that we will get these very specific color divisions. So let's jump up and have a look at one of these closer. So let's jump to my default camera. Let's go to this nice clustered one over here. Zoom into it, and obviously let's just solo the color ramp. Currently we're blasting it out with that strength value. But you can see here, we now have this very specific color palette. And I could change that if I go, I've got them all selected, so it's changing them all, but we'll just drag this on. Let's reduce the number down. Let's just do 3. Let's drag those on instead and change them to step. And then I have to make sure they're distributed. So distribute them all. Like so, and now that means they're even divisions of 33%, 33.3 recurring, a third. And you can see, if I move this purple knot, you'll see, and I'll shrink the green one, we get a very nice way to control the amount of colors, and it's from a very specific color palette. So that's a new way of assigning colors, but I'm going to be going for only 2 colors, so let's remove one of the knots, right click, distribute the knots, and then let's change the color. Let's do a red for this first one. So let's make it similar to the Peony in saturation and probably notch it down a bit in brightness. And then let's grab this one. Let's make this blue. Somewhere in that region. And then fairly saturated on that one. We'll see how it reacts to the brightness. So let's unsolo that. Now that looks pretty wiped out in terms of color. However, when we set the bloom up and stuff, and you can actually see it as they get further apart from each other and a bit smaller. So as I scrub along, you see they become a bit more natural in color. If I now added a bloom effect to our camera, we'll actually see this color more obviously. So let's do that now. Let's add a cycles tag to our camera. So right click it. You can add a cycles camera tag, and let's actually jump into the camera. There we go. And that will update in the real-time preview. And what I'm going to do is I'm going to activate our post effects. So we've got all the options here for depth of field, motion blur, that kind of stuff. But really what I'm interested right now is the bloom. There's also these glares and vignettes and stuff like that. But let's just focus on the bloom here. And really I'm going to use this as a guide. I'm not going to use this as... I'm not going to render this out. I'm just going to use it as an idea of what it's going to look like when we get it into our compositing program. So you can see here I can reduce the radius around the particles a bit, like so. And you can see that color is really showing off now. But the centers are staying quite hot. And that's why I wanted to keep that value up at the level that it is, 30. So I'm just going to dial in these settings. I've kind of got a rough idea of what I like to use. And the threshold is just sort of including the darker particles. So it sort of clips out some of the brighter ones. And then if we drop the intensity right down to about 20% or so. That's good. And the bloom radius can be pretty small as well. There we go. So it's nice and subtle. A subtle effect, but it'll show nicely on the bright particles. And you can see it's really selling the color now. And then obviously our big crescendo with the willows. Like I said, I'm only using the bloom just to sort of get an idea of what it's going to look like in the comp. And what I'm going to do is I'm actually going to assign that same material here. And currently, it's the willows have that white material, but let's give them this, well, let's call this red and blue. So, red and blue. And let's have a look at our emitters. And it's actually the stars that I'm interested in. So stars, and it's these ones. So it's all the ones with the blue layer. That's why the layers are also very useful. I'm going to just right click, apply that material, and it should automatically assign them. There we go. So you can see now we've got half the particles, half the stars are the red and half the stars are the blue. Excellent. So let's just scroll back through, check some key moments. So there's our multicolored bombettes, very nice. Scrub back down here, a little bit further back to see the peonies. So there's our green one in the middle, blue left, and the pink one. They're looking really nice. Okay, and let's just check our fountain here. Excellent, nice and bright. Now, there's a couple more tweaks I might make. The background at the moment, we're not really seeing that pylon there, and this is quite. This would be quite a nice backing for the platform to sort of contrast against. So I'm just going to tweak that a touch. Something about there. So that's looking nice. And then what I might do is I might change the materials on the surface on the ground here. Now the ground surface is about the right tone, but I'm going to take it off of the platform here. So currently these are just C4D materials, but Cycles can interpret them. So it is just using the diffuse channel of this standard Cinema 4D material, but it's always safer to add an actual Cycles material. So I'm just going to drop a diffuse BSDF on there. I might make it a bit brighter, we'll see. Oh, that looks quite nice. And then I'm going to add this one. I'm going to use that 21% brightness grey, like so. I'm just going to replace this one here. So if I hold down Alt and drag it onto there, any material in the scene would have that darker grey, and it swaps the assignment over. So, okay, let's call this Psi. Well, actually, I can leave them diffuse BSDFs, and then dark grey. Light grey. Okay, and that just means that we can see a little bit more of cast light onto the platform there. Excellent. One last thing we're going to have a look at is also knocking out the silhouette of the trees in the foreground. Let's go to one of the later frames. And we can see here we've got the tree on the right. It's quite subtle at the moment. There we go. We can see that quite clearly, and it's quite crisp at the moment. So what I want to do is I want to add a bit of depth of field to the camera. So if I go into the camera tag, the Psi camera tag, and jump to the settings tab, depth of field, and you can see here we can play with the f-stop or the radius value. I'm going to make it radius, and if I increase it quite high, you'll see that it knocks out the foreground a little too much, and even knocks out some of those particles. Now, the focus distance is what this is all basing the blur off. If I go to the object tab of this, you'll see that it's actually controlled by the target object that we've already got in the scene. So I'm actually happy for it to use that, and it'll actually keep the particles nice and crisp. But you can see I'm forcing it to be way too shallow here. So really, I just want it to be 1/10 of that, because that kind of makes it look a bit artificially small, but just enough to knock off the the sharpness of this foreground tree. Okay, and just check that at the beginning as well. Excellent. Okay, so we're nearing completion here, and one of the very final things you tend to do is go through your render settings. So let's open up the render settings here. You can get that with Control B, or it's also up in this menu under Edit Render Settings. But we're going to just add a new render setting down here, make it active, and I'm going to rename it Cycles 4D. You can call it whatever you like. And let's make sure it's using the whole range. That's 560. And then let's change the renderer to Cycles 4D. Okay, so I'm going to leave the res at 1280, 720 right now, whilst we're just doing some final tests. But I will increase that to double that resolution at the end. So let's jump to the Cycles 4D render settings. And I'm just going to keep the RTP in view. Now the device is defaulted to CPU, so I'm going to change that to CUDA, and then I can make sure that it's utilizing all my devices and all that kind of good stuff. But the settings that we're only interested in at the moment, we can collapse performance. Now, what we're going to take a quick look at is the clamping. So if we move to a frame where there's a few more particles, maybe where they nice and bright. What we're going to do is we're going to work a bit with the clamping here. So what clamping does is if I set that to 1, essentially it's not letting any ray add more than that value. It's clamping the value of the pixel essentially. So it's not allowing that pixel to become any brighter than this value. So it darkens the image quite significantly. And the difference between clamping direct and indirect is that indirect rays have had one bounce at least. So they've bounced off something. So that's all the stuff under here essentially. But the direct stuff is exactly what you're seeing like on the particle itself. So we don't want to clamp them that much. We lose our nice hot looking particles. So I'm just going to leave them up at 10. And then the indirect, we don't need that to be quite as significant because we don't have many bounces in this scene. So I'm actually going to set that to 3. You could probably go even lower, but I think that's going to work for us now. Now our maximum samples, obviously we want them to be, for the final rendering, we're going to want them up kind of towards the late 20s, 30s. But that really depends on your scene. Sometimes you can get away with a little bit lower. Sometimes higher is better just to clean the image up. Right now, I'm just going to set that to something like 8 whilst we're just testing a few things. So let's close that down. We don't need that anymore. We don't have to worry about the ray depth and the bounces and stuff like that. But what I do want to have a look at is I do want to have a look at the motion blur. So I'm going to actually activate motion blur. And then I'm going to close this window. We'll come back to it in a bit. And what I'm going to do is I'm going to render to the picture viewer. So actually, let's change the range that we're going to render. Let's start a bit later on. So let's start around about 100, because then we'll see some nice motion blur from this explosion, this break. So output, we'll start at 100. And I'm going to leave the bloom on right now, but at the end, we're going to actually turn that off. Let's just expand our motion blur in the Psi camera tag as well, just to check that out. And I'm going to just notch the samples up a little bit, just so we can see it nice and clearly in this test. So I'm going to drop them to 24. Then I'm going to hit render to picture viewer. So render to picture viewer. It's going to warn me that I'm not saving it. That's no problem. I'm just testing. And let's let that process. Now what this is going to do, this is actually going to add motion blur to our particles. In fact, it's adding motion blur to our entire scene. And it'll give the sort of much more realism to them. Instead of them being points, it'll actually treat them as if they've got that motion and the camera shutter is being open at a certain period of time. So you'll see here, now I've got this active, we actually see some lines instead of just the dots. And that really adds to the realism of the particle motion. Okay, so this is our first frame. Now what I'm noticing is that the motion blur is quite straight, so it doesn't taper off at all. And I want it to taper off a little bit just to kind of give them a different look. So I'm going to stop that render, interrupt it like so. And on here, on the shutter curve, I'm actually going to drop that down there. I'm not going to play with the shutter time. Essentially, a longer shutter time would mean longer lines or longer trails, if you like, behind the particles. But I'm just going to play a little bit with the shutter curve here. and I'm going to send that back to the picture viewer. What this is going to do is this is going to actually give the motion blur tail a little bit of a kind of it sort of tapers off a little bit, and I just like the look that it gives. So let's let that render. It doesn't take too long to load in, and there we go. So if I jump between those, you can see the difference. So they're just tapering off a little bit, and they're hotter at the front of the particle than they are at the back. Okay, so I'm pretty happy with that as our motion blur. And one last thing that we're going to do is we're going to add a render pass as well. So currently, if I render the beauty, we have no way of isolating the fireworks from the background at all. And so what I want is I want to actually be able to have the fireworks on their own layer so I can create blooms and different color effects in post. So if I just jump to render elements here, all I need to do is, because of all our particles, all of our fireworks particles are emissive and giving off light, I can just check that one on. And then over here, I need to just add a post effects in the multipass. So if I hit multipass, activate that, it'll allow us to save a multipass out, right click, and then we hit post effects. And if I close that, and whilst I'm here, let's turn off our actual bloom post effects. Close all those down. And let's just render a test frame just to make sure that we're exporting that emission pass. And that will actually sit in here with the beauty as well. And then once we've done that, our scene is ready to render. So it's looking really nice. You can see that we're going to get that nice heat as the break occurs. It's going to give us a nice sort of really hot area. So let's check that new render out, and let's jump to the layer. And if I do single pass, you can see we are only seeing the emission layer. So if I jump between those, you get exactly what you're getting is the beauty, but just the fireworks. Okay, so I'm going to set that up to render at full resolution. So I'm going to do it at 2560 by 1440. I'm going to do the full range, and then I'll probably increase the sample count just to make it nice and clean. And then we'll render that, and then I'll see you in the next part where we will composite.